Yeah. Let me do another transformation problem. I've got my brother holding the camera for me, so this should be a little more study here. So if we want to graph this, notice this function has two transformations. That 2 there is right inside the function. That's a horizontal shift, and isn't that -1 in right field? So that's a vertical shift. It's good to identify the transformation. So we got 2 of them. So which is the basic function? This is a bit of an art form. I wrote down some of the library of functions right here. And it's one of them, it's this one. Do you see x in the square root? And over here, don't you see x underneath the square root sign? So the basic function is going to be this. I mean, sure, you could graph this using a table of values, but this is a kind of a faster way. So this is why we like to do the transformations. So first thing, let's graph this function. And we should know that it looks like this, because again, we should have these library of functions all memorized. So that's what that equals. I'm going to label a couple points here. How about the vertex? If you have a vertex, always label it, or an endpoint, because that makes it easier to find the domain and range for the final stage. So I'll label one more. If I let x randomly equal, I want to pick a perfect square, since I want to take the square root of it eventually. I'll let x randomly equal 4. And then what's the output going to be? What's the square root of 4? 2. Okay, so I labeled 2 points on my basic graph. Now let's go one transformation at a time. So I'll go over here, and it doesn't matter which one I do next. Sometimes order matters. Here it doesn't. If you ever have a vertical shift, though, always do that last. You can't go wrong with doing the vertical shift last. So I'll do this for my next stage. One transformation at a time. So I'm going to go like that. Be meticulous. Make sure the 2's underneath the square root sign. What is this function going to look like now? This is the beauty of doing these transformations. This function looks remarkably like the prior graph or function, except we're going to do a horizontal shift. We're going to shift this prior graph 2 units to the left. So watch how we do this. Boom! See how quickly we can do that? All I did was shift this graph 2 units to the left. What do you think is the endpoint here now? Doesn't the horizontal shift say affects all previous x coordinates? So subtract 2 from all previous x coordinates. So the vertex now becomes -2, 0. And what is this point going to transform to? Subtract 2 from that x coordinate. What's 4 minus 2? 2. And you leave the y coordinate the same. So make sure you plot it in the right spot. That looks like it could be 2, 2. You can do a test check if you want. If I let x equal 2, is the output going to be 2? What's 2 plus 2? 4. What's the square root of 4? 2. Yeah, so that's a good sign. And now all we have is one transformation left. Let's do f of x equals the square root of x plus 2 minus 1. That's the whole enchilada there. And what is this graph going to look like? It's going to look remarkably like the prior graph, except we're going to drop down this graph 1 unit. That's what that vertical shift means. It affects the y-axis. So watch how quickly we can graph this. Done. Done. And what is this endpoint going to be? I subtract 1 from all previous y coordinates. What's 0 minus 1? -1. So -2, -1. And what is this point going to become? 2, 1. Right over here. 2, 1. And that looks good. What's the domain and range now for the final graph? That's all we got to do. Domain and range. What's the domain going to be? Again, here's the x-axis, here's the y-axis. Domain is like extremes, from low to high on the x-axis. Isn't this the smallest x coordinate? So go low to high. So -2, and then what's the other point? What's this going to be over here? Notice this arrow. Doesn't that go forever? So it covers the entire x-axis over here. If I draw a vertical line on the x-axis, it will hook up with the graph. So that is going to be infinity. Oh, infinity always takes a rounded parenthesis. Or I could write the domain like this. X is greater than or equal to -2. Make sure you use the variable x with domain. These are saying the same thing. Okay, and then what's the range going to be? So the range, What part of the y-axis is being covered by the graph? What part of the y-axis is being covered by the graph? That's what range means. Isn't this the smallest y-coordinate? Always go small to high. So I'm going to start off with -1, and then look at the y-axis. This is going to the right forever, the graph, but it's also going up forever. So in other words, if I draw like a horizontal line over here, wouldn't it hook up with the graph eventually? Sure it would. So it looks like this is going toward positive infinity on the y-axis. So it looks like infinity. That's what it's covering all the way up to infinity on the y-axis. Or you can write it like this: y is greater than or equal to -1. And that looks good.
This is called interval notation with the parentheses and brackets. This is just called inequality form. And most of the time they want interval notation. So this is preferred to that.
One more problem.
This is preferred to that.
Even, odd, or neither. So we're shifting gears here. Is this function even, odd, or neither? Even has symmetry about the y-axis. The graph has symmetry about the y-axis. An odd function has symmetry about the origin. And neither means there's no symmetry about the y-axis or the origin. It's always going to be one of them, a function. And how do you find out whether a function is even, odd, or neither? You always find f of -x first. My brother got tired holding the camera, so now I'm taking over here. So always find f of -x first whenever you're asked on a test, is a function even, odd, or neither. So I'm shifting gears here. This has little to do with transformations. Okay, so find f of -x. You need to do that first. Okay, so this is evaluating a function. Plug in -x for all x's. I even did it for that x there. What am I going to plug in then for this x? -x. And I got to square it plus 4. So that's a good first step. And then simplify. What is that going to be? What's -x all squared? Isn't that a positive x squared? Plus 4. And then once you find f of -x, ask yourself, does f of -x equal the original function? I'll put a question mark there. If that equality holds true, then it's going to be an even function. This is how you show it algebraically, whether a function is even, odd, or neither. If this holds true, it's an even function. Let's see if this holds true. Does f of -x, which is this, does that equal the original function, f of x? It does. So that means it's an even function. Those are the easiest when it's an even function, because you can just stop right there. Let's do one more. Even, odd, or neither. How about if you have f of x equals, say, x cubed minus 7? Is that function even, odd, or neither? What do we do first? Find f of -x. So I'll go like that. And what does that equal? Plug in -x for all x's. So that's a good first step. And then simplify. What is -x all cubed? What's -x times -x? It's x squared times -x is -x cubed minus 7. So we have that for f of -x. And notice, does f of -x equal the original function? Nope, they got to be exactly alike, and they are not. This term is negative here, it's positive there. So that means it's not an even function. So that means f of x is either an odd function or neither. So what do we do next? Next, you got to find negative f of x. What is that going to equal? All that means is you take -1 and multiply it by the original function, f of x, which is x cubed minus 7. That's what negative x means. Negative f of x, rather. You just take your original function and we'll multiply it by -1. That's what I did here. And simplify. What is that going to be? Using the distributive property, you get -x cubed plus 7. Now what you do is ask yourself this. Does negative f of x equal f of -x? I'll put a question mark there. That's what you always have to do next. If that equality holds true, then it's going to be an odd function. Let's see. Is that true? f of negative x is this, negative x cubed minus 7, and negative f of x equals negative x cubed plus 7. They are not the same. That's a minus and that's a plus. So therefore we can conclude it must be a neither function. Neither. So that's the technique you do to figure out if a function is even, odd, or neither. It's all algebra we're doing. First thing you got to do is find f of negative x, compare it to the original function. If they're the same, then it's an even function. But if they're not the same, then you got to find f of negative x, and is it equal to negative f of x? If that equality holds true, it's odd. But if that doesn't, if they both don't, then it's going to be a neither function. So notice that why it's so important. You have to find f of negative x right off the bat, because you need that for deciding if it's an even function or an odd function. If it's an even function, you can stop right away. In this case, it wasn't an even function, so we had to keep going. All right, good enough. And next time, I'm going to revisit this problem right here, the piecewise defined function. Let me just give a little quick thing here, because I noticed this is on the written assignment that I assigned. With this piecewise defined function, let's just do this simple thing first. Find f of how about negative 3? What would f of negative 3 be for this piecewise defined function? These are the imposed domains. These are just commas here. Isn't negative 1 the smallest x? It's always that top left. This is the smallest one. This is saying for all x greater than negative 1 and less than or equal to 4. Negative 3 is not even in the domain. So this is undefined. So there's no answer for this one. It's undefined. When we graph this function, there'll be no graph at x equals negative 3. Let's try this one. Find f of 0. What would that equal for this piecewise defined function? So you got to look at these two imposed domains. X equals 0, which one is it in the domain? Isn't it in the top one? Isn't 0 greater than negative 1 and less than or equal to 4? Yes. Notice 0 is not in this domain. Remember, this is always an x value in those parentheses. 0 is not in between 4 and 8. So when I find f of 0, that means first I got to pick the right equation where 0 is in the domain for. It's in this domain. So go to that top equation. What's 2 times 0? 0. So that's the answer. So in other words, wouldn't 0, 0 be a point on this function? Sir. How about find f of 4? That one's an interesting one. What is f of 4 going to equal? Because I see a 4 here and I see a 4 there. Which one is 4 in the domain of? The top function or the bottom function? And let's see. It looks like it's in the top one because of that equal sign. Notice 4 is not in the domain for the bottom equation because there's no equal sign there. So what's 2 times 4? 8. Oops, 8. That's the answer. 8. That's a scribble mark there. 8 is the answer. Wouldn't 4, 8 be a point on the graph? And one more. What about f of 5? What is f of 5 going to equal? Which equation is it in the domain of f of 5? Isn't 5 not in the domain here, but it is in between 4 and 8. So 5's in the domain for the second equation. So go to the second equation. And there's no variable there. It's always going to be 7. Y equals 7. So the answer is 7. Right there. F of 5 equals 7 for that one. All right, folks. I will see you next time. Bye-bye.